Hello, mathematicians, and welcome to day 3 of real numbers. Please make sure you have 3 things in front of you. Make sure that you have a blank template of these notes. You're going to have to write day 3 on here. And that you have your green sheet out. So, what we're going to be talking about today are 2 things. We're going to be talking about the zero rule and multiplication rule. Now, what I would like for you to do is I would like for you to create a chart with 3 lines on it. And let's add in about 4 rows. Let's make it 5. Now my iPad is a little special because it can actually create straight lines for me. Now let's pretend I had, let's work with their 2's. Pretend I had 2 to the 4th right here. Well, what is 2 to the 4th? So let's do our exponent version right here. And let's do our expanded right here. But if I were to expand this out, this would be 2 times 2 times 2 times 2. Now, what is that? Well, if I were to get a calculator or do it in my head real quick, this is 16. Now, let's do 2 to the 3rd now. Let's keep going down. Well, that is 2 times 2 times 2. Now, what is that? What's 2 times 2 times 2, or 2 to the 3rd power? You should get 8. Now, let's keep going down. 2 to the 2nd. That's easy. That's 2 times 2, which is 4. 2 to the 1st is just 2 by itself, and my answer is 2. But now, this is where the zero rule comes into play. What if I had 2 to the 0? What does that even mean? Okay, what would my answer be? Well, the way that mathematicians figured this out is that they looked for a pattern. So let's focus on our right-hand row right here. If I wanted to go from 16 to 8, what would I have to divide by? 16 divided by 8 is 2. So that means if I did 16 divided by 2, I would get 8. Now let's keep going. From 8 to 4, I would also have to divide by 2. From 4, to get from 4 to 2, I would also have to divide by 2. So mathematicians figured out that in order to find out what 2 to the 0th power is, they would have to do 2 divided by 2. Now what's 2 divided by 2? 1. So this works with any exponent. So the 0 power states is that any number to the power of 0 is equal to 1. So that means 5 to the 0 is equal to 1. That means 2 to the 0 is equal to 1. That means 10 to the 0 is equal to 1. And that means 1,000 quadrillion billion to the 0 is equal to 1. So that is the zero rule. Now let's talk about the multiplication rule. So I'm going to actually draw a line right here. And right here, I'm going to write on my side that we covered the zero rule. And now we're going to talk about the multiplication rule. Oop, that's not going to fit. Multiplication. Now, pretend I had, so let's do an example. Pretend I had 2 to the second times 2 to the third, okay? Well, let's see what happens when we expand it. So if we were to expand this, let's pretend that this is my purple version, and this is my pink version. If I were to expand this, I would have, for my purple, I would have 2 times 2. And for 2 to the third, I would have 2 times 2 times 2. So remember, I'm expanding it right here. Now, what would happen if I were to compress these again? They all have the same base, so I can do 2. But how many 2's do I have now? 1, 2, 3, 4, 5. I now have 2 to the 5th power. Interesting. Let's try another one. What if I had 3 to the 3rd times 3 to the 3rd? So again, you can color code this. So let's say this is my purple. My pink, I mean, and this is my purple. Well, then for my purple, 3 to the 3rd is 3 times 3 times 3. And for my pink, it is also 3 times 3 times 3. And since these are all the same base number, also the 3's are all the same, I can squash this again so that I have 3 and it's multiplying by itself 1, 2, 3, 4, 5, 6 times. So can we somehow find a connection? Right here, we had 2 to the 3rd times 2 to the 5th. Or let me color code this real quick. We had 2 to the 3rd times 2 to the 2nd. Oops, I accidentally wrote it backwards, but you get the gist. And at the end, we got 2 to the 5th. On my right hand side, I had 3 to the 3rd times 3 to the 3rd again. And I got 3 to the 6th. Now, if we focus on the exponents, you should notice that we are just adding these two numbers. So technically, this is equal to 2 and then we did 3 plus 2. We added our exponents. Same thing over here. We had 3 and we added our 3 plus our another 3, which gave us 6. So our actual cheat sheet to this is that you can, when they're multiplying, you can add the exponents. But this only works if they have the same base. So we have to write right here, must have the same base. Now I actually copied a Delta math problem, so you can go ahead and stop the video here, or you can keep following along. So this is an actual Delta math problem. It says 3 to the 3rd times 3 to the 2nd. Do the bases match? Yes, they do. So I know that this is going to end up being, oops, 3. You keep the same base, so keep the base. And then I'm just going to add my exponents. So it's going to be 3 plus 2. So my answer is going to be 3 to the 5th. So here I would put 3 to the 5th. Now, what happens if my bases don't totally match? Let's look at the second problem right here. What we can do is that we can group them. So I see that I have my 2's right here. I have my x's right here. And then I have a lonely y. So let's focus on my 2's. Okay. What are my exponents? I have 5 and 2. And since they are multiplying, I would add them. So this would be 5 plus 2. Now let's focus on my x's. I have an x. I'm going to keep the base. And what exponents do I have? I have 3 and 2 right here. So I'm going to do 3 plus 2. And then I have a very lonely y that just has a 6 to it. Now let's go ahead and clean this up. So 2 would become to the 7th. My x would become to the 5th. And y becomes 6. But I cannot do anything else. You cannot add up these different exponents. You cannot add up these different exponents because the bases are different. So this would be the cleanest solution that I have. And remember that they are multiplying. So my final answer would be 2 to the 7th times x to the 5th times y to the 6th. So go ahead and, just last thing, let's go ahead and add this to our green sheet. So remember the 0 power rule, any number to the 0 power is always going to equal to 1. So an example over here would be 5 to the 0 equals 1. The second thing we covered today is the product rule or multiplication rule. And that says that if I have two bases that are multiplying together, I can quickly solve it by adding its exponents. So here I would have keep the base, and I would do a plus b. So let's copy down an example we did. We did 2 to the 3rd times 2 to the 5th. So my answer would be 2, 5 plus 3, which would be 8. Now the next couple things we need to cover is the power to power rule and the quotient rule. But for now, go ahead and stop here and jump on Delta Math.